In Chapter 5, Section 2, again, still in probabilities, again, still make sure we are reading these sections, but we're talking about the general addition rule. And so in the text, they have some more definitions. They'll have some pictures available of then diagrams and how we can represent this. Trying to scroll down, not letting me scroll right now. But we can hopefully look at some of these questions. One of the questions, I think it's going to let me scroll now. There we go. We have Venn diagrams, and we have this addition rule for disjoint, and then we have an addition rule for overlapping regions, so not disjoint, which will be on this next page. But another term that we talk about in this section is we talk about complements of something. So an example is if I was a basketball player and I was an 80% free throw shooter, then what's the chance that I miss? That would be the complement of my 80% and the event happening. So the complement of me making a shot is missing a shot, and so that probability would be 20%. So here, if we're looking for a complement an event, we just do 1 minus whatever the probability of the event happening is. So in this case, I'd have like a 0.66. That would tally to 1. Number 6, so, in the golf bag contains 6 black balls, 3 green balls, and 15 orange balls. So the golf ball is black or green. So if I was looking at a black or green, that means I would add these up and divide by the total number of balls that I have. Again, they are mutually exclusive. They are separate. A black ball is not going to become a green ball. So that sets up for this general addition rule. But we also have things that can overlap. Again, like if we were dealing with cards like these different examples, if I said the probability that I was a heart or a 2, I wouldn't add up all the hearts and all the 2s because I've added one card twice. I've added up the 2 of hearts twice. So this is where this addition rule talks about subtracting the overlap because you've added them twice. So we have to be aware of this when we're doing some of these problems, that they do overlap. Not in this particular case, but in some of the problems. So looking at number 11, they're talking to 383 undergraduate students. Results of the survey are listed below. What's the probability that he or she is satisfied with government? So if we click on the table and we want to see satisfied with government, so we have 232 out of the 383. So this is all satisfied. It didn't give me any condition as far as what rank they were, freshman, sophomore, junior, senior. And we could just say it is this ratio, which I can turn into a decimal, 232 divided by 383. And so let's go ahead and punch that one in. 232 divided by 383. So I get 0.606. And I'll say high five, good job, and we go on to the next question. And if they say, if one is selected at random, what's the probability that he or she is a junior. So a junior. So on this, how many juniors do we have? We have 100 juniors out of the 383. So sometimes you're going to be looking at your rows and sometimes your columns. Sometimes you'll be looking at the individual. So just make sure you're using those general addition rules. Could someone be a junior who is also satisfied? And the answer is yes. We have 70 juniors that are satisfied. So I've said, what's the probability of randomly picking a junior and someone who is satisfied? I wouldn't say I have 232 and this 100 because I've added that 70 twice. That would be my overlap. So a great way to read that table. And then the last one in section 2 wanted to look at was creating this relative frequency distribution. And so when we're looking at this, it says a class width of 10, the lowest one starts at 30. So if the class limits, like that's going to be 30, right? And I know the next one's going to be 40 because that's a distance of 10. But you don't want to have 40 here, so we would go up to 39. And so that's how we would find our class. Finding these counts can be a little bit tedious because I have a table that gives me all this data. So I could bin it that way if I wanted to, but I'm going to show you a way to use StatCrunch to help you bin this data. Because if we had thousands of data, you would not want to do this by hand. But what we can do is we can make a histogram, because the histogram is going to give us an option of starting with 30 and making it a width of 10. And when we do this, we're going to get this histogram, but we can see right here that it starts at 30 and goes to 40, but doesn't include 40 because of that. You'll see that parentheses versus that square bracket. So that means I have 1 in that group, I have 1 in this group, 2 in this group, 6, and so it'll give me those counts, right? It'll give me the frequency that that's happened. And so that's the way, again, we would have to divide by the total to get the relative frequency, but that would be a way to help us out. I believe we can probably get this to give us relative frequency instead. So when we click on it, we can get 0.05 as our frequency, 0.15, 0.3. So that would just be a way of making that problem go a little quicker. And if we had a larger sets of data, make it realistic to do. But that will help you with question 12.